Hello, everyone. Greetings of the day, the authors and invited guests. Welcome to the technical session 11D. Myself, Prashi, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of this conference is being organized in a hybrid mode. The physical event is being held today in Goa, India, and the virtual event is being held through Zoom from 17 to 19 July 2025. I hope you will enjoy the knowledgeable session today. In this session, we have 10 presentations. Each presenter will be given 10 minutes for presentation and 2 minutes for the question and answers. On the 9th minute, I will be raising a gentle reminder. There's another request to all our participants that you all stay connected with us till the closing remarks. If you have any queries or requests, I request you to kindly write it down in chat box to me. Just before we start our session, I would like to introduce you all to our chair for this session, Professor Archana Bhurjwale. She is an assistant professor in Department of Computer Science and Engineering, Artificial Intelligence at Vishwakarma Institute of Technology, Pune, India. With over 12 years of academic experience, her research focuses on AI, deep learning, and computer vision, with a strong emphasis on practical application. Welcome to the session, ma'am.
Thank you, ma'am.
Ma'am, before we start, would you like to say a few words to our participants?
Yeah, sure. Greetings to everyone and a very warm welcome to all the presenters, all the authors to the ICT 10th International Conference for the Sustainable Development. So, as ma'am has already introduced me, so I'm Archana Buruzwali, working as assistant professor in VIT. So, on behalf of organizing committee, I would like to extend a sincere thank you to all the attendees and presenters, and all the best to all the presenters to present their works properly. That's all. Yeah.
Thank you so much, ma'am. Thank you. With this inspiring note, we'll start with our session today. Our first presenter is Simran Negi, presenting a paper on the title A Mechanism for Data Security and User Authentication in Cloud Storage. I request you, if you are available with us, to kindly take over with the presentation, please.
So the topic, as I already mentioned, is a mechanism for data security and user authentication in cloud storage. So we already know that cloud computing provides a very flexible and low-cost data storage. However, it comes with major risks like data breaches, corruption, and man-in-the-middle attacks. So what we have worked on our project that aims to solve these issues by focusing on encryption and user authentication. Cloud computing enables flexible and cost-effective data storage and access. So we already know that there are already existing things that people have worked on cloud storage a lot, but the main loopholes in the already existing systems is that the passwords are stored, which is a major risk in the system if it is hacked. We use same keys in across files, which makes the encryption very predictable, and weak authentication, like no OTP or digital signature validation. So our like system, it works on all of this, and it provides a better and more strong version of the system, which will help in protecting our files. In our system, we are using AES 256 for encryption, and we are also using SHA 256 for key generation. We are not storing any kind of password anywhere. We are also using a salt value, which is used in order to encrypt the file. Here in our system, the file formats that we are supporting are text, image, audio, video, and we are also using OTP-based RSA signing for robust authentication. This ensures the confidentiality, the integrity, and the access control for the cloud storage systems. So the objectives that were to implement a secure and efficient file storage, to maintain the data integrity, and to strengthen the user authentication. So how our system works is we have cloud storage. The user is asked to upload a file. When this file is uploaded, the user is asked to enter the username and the file password. The user will enter both of these credentials, and a salt value will be generated. Then all of these three will be combined, and an SHA 256, the hash value will be created for this, and that hash value will be used for encryption of the file. This encrypt, then the file is stored to the cloud storage, and whenever user wants to like download the file, then they can download the file, and they'll have to again enter the username and the password. In this way, we are not storing, and there is no breach available for our data. In our file encryption, as I already told, username, password, and file, both of these three values, these are combined, and then a hash is calculated, which is then used for the encryption of these files. Here we have the process. The file is uploaded with the file name, and the salt value is stored. Then the key generation takes place, which is with the help of username, salt, and password. And for this, the hash value is calculated. Then AES 256 encryption method is used for the successful encryption of the file. For the file decryption and OTP authentication, the user has to again enter the credentials, and when he or she will enter the credential, then they will have to enter their their email address as well. When an OTP is sent to that email address, they'll have to enter the OTP again, and then the OTP is verified using the signature. The salt value is retrieved, and the key is generated, which is then used to decrypt these files again. The file can be decrypted and can be stored again, and can be used by the author as the user as they want. Here I've shown that the credentials and file passwords, the OTP is requested, then the OTP generated through RSA signing. If the OTP is correct, then the hash value will be generated using all the three: the username, the password, and the salt value. If it is wrong, then an error message will be displayed. If all of these credentials are correct, then only the file is decrypted. Otherwise, a error message is displayed for the user, and the file can be uh, decrypted and downloaded. So the outcomes of the research we have done is that we are using AES 256. So it is very resistant to the brute force attacks, as there are a lot of possible key combinations. So you cannot guess a password. It will take a long time to crack it. We are also using multi-factor authentication, like we are adding a one extra layer in between using the OTP authentication process. And if the avalanche effect, that is, if there is even a minor change in the like the password or the username, then the whole key that is generated for OTP, generated for file encryption, is changed, and therefore the encryption pattern will be changed completely. Here I've also shown an example, like I've taken a file and I've used two passwords, like secure pass 123 and secure pass 124. So when the key is generated and the encryption is done successfully, so you can see that the encryption will be completely different for both of these. So this proves that we are also having that avalanche effect is completely um, satisfied with our. So this is the work we have done. Thank you. Are there any questions?
Yes, Simran, right?
Yes, yes,
Uh,
ma'am.
so I just want to ask that, what is the have you done the literature study for this particular research work?
Yes, yes, ma'am. We went through many papers, and then we finally saw what work has already been done. So then we came out with this idea that the key that we are finally using for encryption can be used in such a way, like we are using three different credentials. We are using the salt value, the username, and the password, and then we are combining it to make the key, which is a lot more secure than the already existing methods.
Okay. Your paper is describing that the key generation process you are using, I think, the SHA-256, right?
Yeah, we are using SHA-256 to calculate the
So,
hash value.
so there are some other functions also, right? Some other functions are there, that is SHA-3, Blake 2B, right? So why you
Yeah.
have chosen the SHA-256? Is there any specific reason for that choosing the SHA-256 over the others?
Uh, Sorry, ma'am, can you please, your voice was a little cracky.
Hello, am I audible now?
Yeah, ma'am.
Okay, I'm asking that the paper is describing the key generation process, which involves that SHA-256, right? Huh.
Yeah, ma'am.
So I just want to know that why you have chosen the SHA-256 over the other hash functions which are available, that is SHA-3, Blake 2B. So is there any difference between them?
So SHA-256, why there's not any particular reason, like we wanted to create the hash in order to make it more secure, and SHA-256 like is a new, no, it is comparatively newer and it is more stronger than the other versions, so we used it.
Okay, and that salt value will be the means it will be the separate for all the users, right? It is
Yeah,
used.
yeah. Yeah, every time the sort we are using a in our code we are using a function, and it is responsible for generating. So every time this function is called, a completely different value will be generated.
Okay, so in previous paper, whatever you have studied, so no salt value was generated in that?
No, there was, yeah, we read one paper. They were creating a hash value using the salt, using like they were creating hash, but we saw that no paper was there in which the key was being generated using three different parts. So we used that in our research.
Okay. Yeah. Thank you, Simran.
Thank you. Thank you so much, everyone.
Thank you so much for your presentation, ma'am.
Thank you.
Now, I would like to call upon our next presenter. Our next presenter for this session is Jalindra Ekatpuri, presenting a paper on the title Advancing Crop Cultivation Estimation with Aerial Imaging and Artificial Intelligence, a Comprehensive Review. I request you to kindly take over with your presentation.
Good afternoon. I am Jalindra Ekatpure. I am the research scholar of AISSM College of Engineering, Pune, and which is affiliated to Savitribai Phule, Pune University, Pune. Now I am presenting one of the conference paper in an international conference on ICT for Sustainable Development, ICT4SD conference. My paper ID is 916, and the title is Advancing Crop Cultivation Estimation with Aerial Imaging and the Artificial Intelligence, a comprehensive review. And the author, I am the Jalindra Nivrutti Ekatpure, and my colleague is a Dr. Dinesh Bhagwan Hansate. Now, some of the contents related to in this paper: introduction, background work, aerial imaging in agriculture, artificial intelligence in crop cultivation estimation, different techniques for crop cultivation estimation, conclusions, and the last point is the references here. Okay, now let's hear what exactly the introduction behind this review paper. The agriculture technology services the crop conditions such some growth changes in a field, in this way boosting yields and making good farming which is sustainable. AI technology partially, those based on the machine learning and deep learning, may be used to extract useful information from the data, allowing us to accurately anticipate how much crop to grow here. These images are evaluated using AI algorithm to detect the crop health, identify alignments, and the forecast itself. Now, to address these issues, further research is needed as well as the development of farmer-friendly technology here. Now, some of the background work here. In that title and year of the paper. The paper which is in the 2024, it is an isolation of Earth observation data for the crop yield estimation in a smallholder agriculture system. In that system, the methodology which is used here, Earth observation data assimilation, and the data source will be the Earth observation data and application smaller yield estimation here. Whenever reading this paper, I want to find some of the key points here. Support for the smallholder farmers through the improve the crop administration process. And in that, some of the challenges related to in this paper, accessibility and implementation in a resource limited setting here. These are the some of the background work related to the first paper. And the another paper which is presented in a 2024, it's an economic fruit trees recognition in hillsides, a CNN based approach using the enhanced UAV imagery. And in that methodology is an CNN based approach here. And the data source which will be used here, enhanced UAV imagery here, and the application for the fruit tree recognition. And in that, I am finding some of the points. Okay, improve the accuracy of a fruit tree identification in a hillside environment. And in that paper, which how the challenges is on handling the challenges terrains here. Now the another one paper is an modeling SAR observable by the combining crop growth model with the machine learning. And in that methodology combines with crop growth models and the machine learning here. And the data source SAR observable and the radar data here. And the application is on the crop monitoring. And in that, one of the key is an improve the interpretation radar data for interpretation of the radar data for the crop monitoring by the incorporating crop growth dynamics here. Now the challenges in that paper is on the complexity of integrating physical mode with the AI. Okay, these types of a background which will be worked in that review paper here. Now another one, crop advancing with the machine learning. In that, using the machine learning data from the remote sensing and the environmental data, actual application related to the crop advancement. And the one of the key points finding here, they improve the crop advancement decisions using the ML techniques here. Now the challenges integrating of diverse data and the sources. These are the papers comes under the background works, which will be the different methodologies, machine learning, then the multi-sensor data fusion using the machine learning, remote sensing and the machine learning here, and the machine learning algorithms here. In that, we are finding the best algorithm for that here. Okay, some of the applications also here we are finding the referring the previous papers here. Crop yield estimation, sugar cane crop identification, then the crop selection and the yield prediction here. These are the some of the applications related to the previous work of the paper here. Now another one is an here finding some of the application that is an crop prediction, gas leakage detection, winter wheat yield estimation. These are the applications related to the previous referred papers here. Okay. Then the leaf area index mapping, third paper shows. First paper shows the crop and yield prediction. Second paper shows the crop and prediction. And the third paper shows the leaf area index mapping. These are the applications of previous paper. And here, one of the common method is, and the machine learning will be there. Is and the machine learning. Okay. Now the another one, method, another paper method refers the remote sensing analysis and its application crop growth monitoring. Second paper is an image segmentation. Is the application related to that? These are the background related to the previous work here. These are the some of the selectable papers. And now move towards the next, that is on the aerial imaging in the agriculture here. Whenever finding in that, we are finding some of the parameters, methods, mean accuracy related to that, standard deviation, simple size, and the confidence interval here. These are the some of the table. The table shows the aerial imaging in the agriculture here. Okay, now the first parameter, crop type. Second parameter is also crop type. In that, the method is the different support vector machine or the CNN, and the accuracy, mean accuracy is also different here, 85.4, 91.7 here, and the standard deviation is a 3.2 and the 2.8 here, and the simple size related to the same, that is at the 50, and the first confidence interval is on the 84.0 to 86.8 and the 90.4 here and 94 point to the 90. These are the sum of the 2 points here. Now move towards the third point, that is on crop health monitoring. Fourth point, crop health monitoring, but the method is the difference. Vegetation indices, that is an normalized difference vegetation index, that is an NDVI, but the method is the CNN. Okay, now in that, mean area is to be the 88.5, 93.2 here. The two parameters is the separate same, but the method is the different, and the mean accuracy is also occur in that different here. That is next is on the standard deviation, also different 4.1 and 3.0, and the simple size is same 45, but the confidence interval is the 86.8 to the 90 and the 91.9 to the 94.5. Okay, these are the same parameters. Another one, we are finding the same parameters, that is an yield prediction accuracy. Okay, in that the method is the different, random forest, long short-term memory here.
Excuse me,
These
sir.
are the methods.
I'm really
Also
sorry
here,
to interrupt.
yeah.
We have exceeded the 10-minute mark. I just request you to kindly wind up as soon as possible, please.
Okay, yes, ma'am.
Yes.
Now the another one, the artificial intelligence in the crop cultivations here. Okay, crop type classification, crop health monitoring, yield prediction, soil moisture estimation. These are the techniques here. Okay, now the applications, AI aerial images in the agriculture, crop monitoring, yield prediction. These are the some of the parameters which will be defined here. Soil moisture estimation, disease and the stress detection, crop type detection here. Okay, crop growth also, irrigation scheduling also, nutrient deficiency also, resource optimization, crop mapping here. Now another one, the techniques for the crop cultivation. Whenever finding the crop type classification, some of the parameters here, crop health monitoring used here. Then next one is yield prediction here, and another one is on the summary behind the summary of the techniques for the crop cultivation. This is the technique, the same method, SVM, RF, KNN, CNN, vegetation index, that is an NDVI. These are the methods, some of the applications, techniques, crop type classification, crop health monitoring, yield prediction, soil moisture estimation, and the integration scheduling here. Now the conclusion related to this paper is an AI through ML and the DL support precision agriculture by enabling the crop detection, health analysis, yield forecasting, and the resource optimization. Adoption faces challenges like the poor data, high computational needs, and the limited funding here. Now, another one conclusion point is that the climate and regional difference demand tailored AI models also. Advancing these fields require to quality data, efficient computing, and the collaboration here. AI and aerial imaging can enhance the productivity, sustainability, and the food security through the joint efforts by the experts, developers, and the farmers here. This is the conclusion here, and the thank you. and any questions related to that also. References is also presented here, but some of the 30 to 35 references, that's why I'm not inserting in this PPT because of the minimum time.
Okay. Yes, this paper is a review paper, right? Completely. Hello, am I audible?
Yes, ma'am.
So, are you proposing something out of whatever the review you have done?
Yes, proposing. I have 4 objectives related to the. I am finding some of the objectives here in these papers also. In that sub objective, first one is finding the sum of the searching the sum of the data, or finding the old methods also in that here. And the second one is I am studying the previous methods by using CNN algorithm. And another one is on the some of the comparing the sum of the data here.
Okay. So your review basically highlights various AI techniques, right? Whatever the papers you have enlisted here. So, can you tell me that have you observed any trends where certain AI model consistently outperform for other over the others? For let's say some specific estimation task. For example, you are saying the yield prediction or soil moisture you have said, then resource optimization also. So have you identified something that this particular AI model has outperformed the others for these are the different tasks, as you have studied many papers, right?
Yes, but I am finding here by using the aerial images, one of the best here is, and some of the objectives like that, to study the existing method of the crop cultivation estimation from the aerial images using the artificial intelligence. This is my first objective. Now another
For
one
the so for
objective
the
is
aerial
another
imaging,
one objective is, and to improve the accuracy of crop cultivation estimation from the aerial images using the deep convolutional neural networks, that is, and the DCNN. And another objective is then to optimize the performance of the proposed deep convolutional neural networks model for the crop cultivation estimation from the aerial images. And the last objective, to compare the proposed model with the relevant existing model for the performance validation. These are the some of the objectives here. And before that, after that, I am finding the scope of my project here, my research here. In that, the
and
scope of the research is and revolves around the enhancing the efficiency of crop cultivation estimation from the aerial images through the application of the artificial intelligence technique, that is
okay,
an
and how you are going to process those aerial images?
uh, satellite images.
You need to process it, right? To apply
No,
it
I
from.
am collecting the data set from that.
So you are actually collecting the data set, or you are using some data set which is available?
I am collecting the data set and then using for the next objectives for that data set.
Okay. Okay. Thank you. Yeah.
Thank you, ma'am. If any suggestions, please, anyone can share with me. Any question or any suggestions related to my paper also.
I don't think so, sir. Ma'am is satisfied with the answers. Thank you
Excuse me,
so
ma'am.
much for your presentation. Yes,
Yeah, I'm audible, no, ma'am?
yes.
Yeah.
Okay.
I think so. There is no any type of a question or any type of a suggestion. Thank you. Thank you for ICT also.
Thank you so much, sir. Thank you for your presentation. Wonderfully presented. Thank you. Now I would like to call upon our next presenter. Our next presenter is Rohit Bajirao Khetkar, presenting a paper on the title AI-driven virtual mouse using hand gestures. I request you to kindly take over with your presentation, please. Sir Rohit.
Am I audible, ma'am?
Yes, sir. Now you're on.
Okay, let me start. So, good morning, everyone. Good morning, ma'am. My name is Rohit Khedkar from Vishwakarma Institute of Information Technology, Pune. And today I'll be presenting our paper titled AI-driven virtual mouse using hand gestures. And this in the guidance of Professor Santosh Kumar. Let's go through quickly. So the outline is like problem statement, motivation, objectives, literature review, and some input gestures. So let's start with problem statement. Okay. So problem statement is like traditional physical mouse are not ideal for everyone, especially those with physical limitations. Our aim is to design a virtual mouse system that uses a webcam to recognize and hand gestures and control mouse functions, eliminating the need for any physical hardware. So, so there is a critical need for more user-friendly and accessible alternative that allows seamless interactions with the computer without any dependency or any other external hardware. So, so okay. So, introduction. Uh, With the rise of touchless technologies in healthcare and public kiosks and smart devices, the need for hardware-free solution is growing. Our system enables full mouse functionality using only a webcam and hand gestures. Our goal is to create a virtual mouse system that replaces physical mouse operations using hand gestures via standard webcam. This solution is hardware-free, cost-efficient, and designed for real-time performance, especially useful for individuals with mobility impairments and touch-free environments like clean rooms, public terminals. So the motivation for this is like the motivation came from the need to make computers more accessible and intuitive. A virtual mouse using gestures can assist people with disabilities, improve hygiene in clean environments, and even enhance user experience in gaming and virtual reality. So gap analysis. So existing system and their drawbacks are like from previous years, there are trackball mouse to wireless mouse, wireless ones. Input devices have evolved, but they still rely on physical movement and surfaces. Our system works in any environment using vision-based interaction without mechanical limitations. Uh, so these are some gap analysis. There are also physical mouses subjected to mechanical wear and tear and also require special hardware and surfaces to operate. So in our system, there is no need of any such physical hardware. We using webcam for that purpose. So our objectives are uh, creating a hands-free interfaces, ensuring compatibility with low-end devices, allowing custom gestures and maintaining a user-friendly setup with real-time performance. Okay, so we have gone through some literature review. Early gesture system uses external sensors, colored glows, or infrared cameras. Infrared cameras and that are very costly and non-scalable. Recent solution leverages OpenCV, MediaPipe, and CNN models for gesture recognition via webcam. So basically, we have challenges in this system like cursor jitter due to fast hand motion, low precision in dynamic lighting or cluttered environments, lag in real-time gesture execution. So our system improves that by adding gesture accuracy, environmental robustness, and expanded gesture set, including scrolling, volume, and brightness. So these are the hardware and software requirements for our system, basic hardware requirements. We use the 720p resolution webcam uh, and Python, OpenCV, and MediaPipe for our implementation that runs efficiently even on mid-range laptops and doesn't require GPUs, through it benefits from them. Okay. So the system architecture is like this. First, we take video input, which captures real-time frames using a standard webcam hand detection. Then we do hand detection using MediaPipe, which recognize our hand 21 landmarks like fingers, joint, and wrist. Basically, after that, we use gesture recognition module, which calculates the distance and orientation between landmarks, recognizes gestures like click, drag, scroll, volume, and brightness control. And after that, these gestures are mapped to some uh, functions that does mouse, and then in that system also we use the smoothing filter for uh, guessing accurate gesture. For reducing jitter and accidental motion, we use the exponential moving average. So and our data flow diagram is like hand. We take input through hand, then it goes to web camera, and then we detect hand landmark. Then we process that data or image using media pipe, and then hand gesture recognize that. Then we map the particular action of mouse to that gesture, and then we perform that operation. So basically, as you can see, this is detailed diagram, initialize system and detect hand landmarks, and we here are given all the gestures that we implemented in the system. So uh, left click, right click, double click, uh, uh, cursor movement, and volume increase, down, increase, low brightness control, and drag and drop, which is new feature in all the existing system. Uh, Also, ma'am, can I demonstrate my uh, project through video, as it is based on purely uh, images and function, real time.
Sure, sir, in the given time, yes.
Okay, okay. Let I have recorded that. As you can see, I am able to do the actions using my real-time webcam. This is performing double click. This is for neutral gesture. As we can see, we go through our system, like we can play, pause any video. As you can see, we can access any of the, let me go through scroll gesture and brightness increase, brightness decrease gesture. Okay. So here you can see that brightness is increasing. Okay. By doing this gesture like fingers pinching upwards and finger pinching downward, we can control volume. And in left right direction, we can control brightness. So now go to scroll feature. Okay, let me go through scroll feature. Which is using minor hand, like my left hand is my minor hand, so I can use that. So this is working of scroll down, and this is working for scroll up. Okay, and one another feature is like for drag and drop. So this is used for drag and drop gesture. So this is all the demonstration. Okay, let me go through activity. Second.
Sorry to disturb you, sir. However, we have exceeded the 10-minute mark, so I just request you to kindly continue.
Okay, okay, okay. Okay. So we have tested this using some testing environments. Like we have uh, tested in four environments: static environment, dynamic environment, low light conditions, and uh, daylight conditions. As you can see, the simple gestures like neutral and cursor movement and right click has great accuracy, and also double click. And the other gestures which are complex to perform. So uh, their accuracy is about 80%, 86%. And this gesture recognition technique firstly goes through hand landmark detection using Medapipe, which tracks the 21 hand landmarks, which are given on fingertips, joints, and wrist, which provides real-time coordinates of our hands, which is used to connect our gestures. And for the stability, we use the gesture action triggering only for if our real-time hand is captured after five consecutive frames, and to prevent false positive interaction with that. And for smoothing algorithm, we use the exponential moving average algorithm, which uh, enhances the image of hand in real time, which reduces jitter caused by hand tremors or camera noise. So the conclusion, hand gesture recognition provides a more natural and intuitive way for users to interact with systems compared to traditional hardware. And our system improves the camera-based gesture control can replaces physical input device effectively. It's accurate, accessible, and cost efficient. With improvement in lighting adaptation and gesture complexity, it has great potential in mainstream use. Along with that, we are use the personal assistant to make system totally accessible through our voice and our hands. So no need to interact with physical keyboard or laptop for that purpose anymore. So thank you for that. And if any questions, right? Also.
You said the physical mouse is the physical keyboard is also not required? Something like that?
No, ma'am, not required.
Okay, so you
Basically,
are
for this type of actions like left click, right click, and these gestures for performing that type of action.
okay for performing these type of action. Okay. So one more thing is there that means something are there that is the who will be the user base target you are targeting for that? That is the first question.
Basically, it is for all users, but specifically for the disability, the users who have specifically disabled, they can use this system. Like there are only hands is required for moving the mouse.
So user need to train
So
for
that's
that, right? User training is required here because
yes, you
whatever the gesture you are
yes,
saying
yes,
that, yeah, because you trained the model based on the gesture you have decided. So if the user will do the same
yes, yes,
gesture, then only it will recognize that it is a scroll up, scroll down, or whatever the other mouse operations are there, right? So user training is
yes,
required to that. Then second, next one is I
yes,
feel that accuracy improvement, I think it is required over here. The accuracy, whichever you have shown here, it
uh,
is from up to 75, 80 something, 85 up to 85. So
80%.
that
Yes.
has to be improved. So have you find out any solution for that to how to improve the accuracy?
Yes, ma'am. Basically, I'm going through many literature papers. Their accuracy is also low, but we are currently working on that, and we can use cameras like cameras and performing some image processing as that type of accuracy is for improve accuracy.
For image processing, what you are using?
Basically, we are using here filters like exponential average filters. Let's say yes, only filter.
Okay. Okay. And you said some challenges are there, that is a cursor jitter is there, low precision. How you are handling those challenges?
Basically, this smoothing filter uses used for real time uh, enhancement of image. Like if hand image is uh, in low light, so the exponential moving average filter works on that. Like uh, in the pixel of the image is how low concentration, then average of other filters, other pixels will give to the image. That pixel will improve the image. So that is for reducing pixel. And basically, we are capturing uh, that photo like better than five real-time images or affirmation.
Okay. Okay. Thank you. Yeah.
Thank you so much for your presentation, sir. Now I would like to call upon our next presenter for the session, Shweta Thakral, presenting a paper on the title Intelligent Spectrum Utilization, Challenges and Opportunities in Cognitive Radio Networks. If you are available with us, ma'am, I request you to kindly take over with the presentation.
Yeah. Good morning, ma'am. Is I am audible?
Yes, yes, you're audible.
Is my screen is visible to all you all?
Yes, ma'am, it is visible to us.
Okay. Thank you. Hello, everyone. Today I'm going to present the topic Intelligent Spectrum Utilization, Challenges and Opportunities in Cognitive Radio Network. My paper ID is 925. Yes. My paper ID is 925. The content of my presentation is Introduction, Literature Survey, Research Challenges, Research Opportunities, Proposed Methodology, Conclusion, and the references. Now, what do you mean by the spectrum sensing? In today's world, use of wireless devices has increased significantly with the advances in wireless technology. In the near future, significant growth of connected devices is expected with mass adoption of IoT. Huge amount of spectrum is required to support this increasing number of wireless devices, but the spectrum available is scarce resources. If we check current spectrum allocation chart, it's very hard to find these free spectrum to support upcoming volume of wireless devices and mobile data traffic. So we can say cognitive radio is a concept introduced to attack the upcoming spectrum crunch issues and make the opportunistic use of this spectrum. Now we can see this from this diagram that there are underutilization of the spectrum, which leads to the spectrum holes. A cognitive radio is a form of wireless communication in which our transceiver can intelligently detect which communication channels are in use and which are not, and instantly move into the vacant channels while avoiding occupied ones. This optimizes the use of available radio frequency spectrum while minimizing interference to other users. CR is a hybrid technology involving software-defined radio as applied to spread spectrum communication. The spectrum is shared between the licensed and the unlicensed users. The unlicensed users are called as cognitive radio users or the secondary users. The holders of the license to spectrum are the licensed users, and we can say they are the primary users. These licensed users have priority access to spectrum for which they have license. Cognitive radio enables unlicensed users to access the spectrum owned by the licensed user when licensed users don't need it. The unlicensed users cease transmitting on return of the primary user. Now, this is the literature survey related to my work. In 2015, Yao et al. Has proposed reinforcement learning-based spectrum management, but the challenges he has found are the scalability and the convergence time. Likewise, other also have worked on the same field in year 2016, 17, 18, 19, 20, 21, 22, 23, and so on. Now let's come to the limitations of the cognitive radio. These are the spectrum sensing, spectrum management, spectrum sharing, and the spectrum mobility. Now, what do you mean by the spectrum mobility? The function of the cognitive radio is to perform transition to a better spectrum, that is vacate the channel when licensed user is detected. The primary objective of spectrum mobility in CRN is to perform seamless channel switchover while sustaining performance of ongoing SU communication. To this end, spectrum mobility is divided into two processes: spectrum handoff and connection management. Spectrum handoff means the process of transferring ongoing data transmission from different channel to another free channel. This naturally causes additional latency to SU communication that eventually affects the SU performance. To compensate the unavoidable handoff delay, connection management process manages and adjusts the protocol stack parameter depending upon the current situation. These are the issues in the spectrum: search for the best frequency band, protocol stack adaptation, self-coexistence, and the synchronization. Now, these are the explanation for these 3 points. Search for the best frequency band. In this, we have to search out which band is best, in which we, for this, we have two approaches: proactive approach and the on-demand basis approach for searching out the best frequency band. And for the stack adaptation, due to the high latency because of the spectrum handoff, the performance of the cognitive radio user gets degraded. Therefore, modification and adaptation of other components in the protocol stack are required. In the self-coexistence and the synchronization, when the unlicensed user performs spectrum handoff, two issues have to be taken into account. The target channel must not currently be used by any other secondary user. And the second one is the receiver of the corresponding secondary link must be notified of the spectrum handoff. Next one is the message broadcasting mechanism and the routing metrics and the route selection. In a message broadcasting mechanism, we have to check the efficient broadcasting mechanism based on the dynamic spectrum access. Whereas in case of routing matrix and the route selection method, due to the activity of the licensed user, the connectivity between the nodes of unlicensed users can be dynamically changed. The routing matrix has to be jointly defined based on the network parameters and the spectrum management parameters. Now, this is the diagram in which we can easily show that how the licensed, in between the licensed users, unlicensed user get the bands for their cognitive radio purpose. Next, we have the traffic management. The modification need to be made to TCP and UDP working in a cognitive radio environment to avoid performance degradation. The congestion control in TCP depends on the packet loss rate and the round trip time. The packet loss rate is affected by many factors like transmitter power, bandwidth of the spectrum hole, and the interference level, whereas the round trip time can be affected by delay due to the spectrum sensing and delay due to the spectrum handoff. Since the different components are ordered in the layered structure, each component has to be operated sequentially. The sequential operation results in computation overhead and the latency. With the layers being isolated, the components in one layer may not be able to access information in other layer. As a result, the interaction among the components in the different layer is limited. Some components uh, can have the redundant function also in this. So the objective of cross-layer design is to increase the information flow between components in different layers. The cross-layer optimization improves the overall performance of communication system through optimization of decision variables and parameters in different layers simultaneously. So this is the diagram for the cross-layer. In the cross-layer, the different challenges are multi-objective system, information access, parameter control, and the complexity. Now, what do you mean by the multi-objective system? The component in different protocol layers have different objective. In the application layer, the high-quality video is required to satisfy the users. However, transmitting high-quality video could incur the congestion in the network. Such trade-off in different protocol layers have to be compromised to achieve the optimal performance. In case of information access and parameter control, to support the intelligent algorithm, to access the information and control of the protocol parameters in different layers would be required. And in order to maintain the layered structure of the protocol stack, the level of information access and parameter control should be limited. So we can say cognitive radio design must compromise between the modularity and the adaptability of the protocol stack. Next one is the complexity. To increase the optimality of system performance, the cross-layer design approach needs to be chosen, but as the number of control parameter increases, the complexity of the optimization also increases. So we can say the cross-layer design-based cognitive radio must compromise between the optimality of the system performance and the complexity of the cognitive radio system. Now, this is the proposed methodology on which we work in future. That is the hybrid spectrum sensing, deep learning based signal classification, cooperative sensing with trust management, adaptive thresholding via context awareness, and the performance evaluation. These are the proposed methodology for us in future. Now, these are the future work that can be integrated in our work. This is the AI and the deep learning integration, blockchain for the secure coordination, edge and fog computing, cognitive IoT integration, sustainable CRM. Now, these are the references that we have referred. Thank you all. So this is all about my presentation.
Hello.
Hello.
Yes. Can you go to the research opportunity wala PPT?
Yeah, proposed methodology. Yeah, research opportunities.
So have you worked on this, any of this AI
Right now we
development
have do
with
the
the
right now we have done the extensive literature on that, but we have not worked on that because it's an extensive literature survey paper. So we have done the extensive literature. Uh, what are the work that can be done on the cognitive radio? What are the limitations? What are the parameters on which we can work out? So we have just find out the problem, identify the problem and the gaps, so that in future we can work on that particular gaps.
Okay. So you're identifying the gaps. So do you have any
Yeah,
proposed methodology or plan for handling the cross-layer design challenges, as you mentioned in the slide,
yeah.
that there are multiple challenges are there?
Yeah, there are multiple challenges. For this, we will use the hybrid spectrum sensing method and the deep learning based signal classification method to overcome all these challenges.
Okay. 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 So this is completely review study, right?
Yeah, it's a completely review paper.
Yeah. Okay. Thank you.
Thank you, ma'am.
So much for your paper, ma'am. Thank you so much.
Thank you.
Now I would like to call upon our next presenter, Mr. Archit Bhagat, presenting a paper on the title NFC-based smart attendance system using YOLO algorithm. I request you to kindly take over with the presentation. Mr. Archit?
I will be presenting
Okay.
on his behalf. So,
Okay.
hello everyone. I'm Athurva Bondade, currently pursuing my BTech second year at Vishwakarma Institute of Technology at Artificial Intelligence and Science Wing. I'm here to present the paper ID 900, that is NFC based smart attendance system using YOLO algorithm that was done under the guidance of Professor Sheila. ma'am. So, traditional waste management, traditional waste collection system rely heavily on manual verification and record keeping, making them prone to human error and fraudulent reporting and inefficient resource utilization. Municipalities lack reliable mechanisms to ensure that garbage bins are actually emptied, leading to unsanitary condition, poor route optimization, and limited accountability among sanitation workers. There is a critical need for an automated, accurate, and real-time solution that can verify waste collection events, eliminate false reporting, and enhance operational efficiency without relying on manual oversight, complex infrastructure. So, with the rise of smart cities, technologies like artificial intelligence and IoT offer innovative solution to these challenges. This project presents an AI-based waste monitoring system that integrates NFC technology with a lightweight YOLO object detection model deployed via TensorFlow Lite. The system enables sanitation workers to scan NFC tags on garbage bin using a mobile app while simultaneously validating bin status through an on-device image recognition system. This ensures that the bins are not only marked as empty after visual confirmation, enhancing transparency, preventing fraud, and enabling real-time data logging, all in a scalable and cost-effective manner. So this diagram represents the system architecture of our project. What happens is that each garbage bin has an NFC tag that has a unique ID associated with it. Our mobile app has the ability to scan this NFC and also runs an YOLO model on it to check if the bin is empty or not. First, the bin is checked if it's empty, and then only you are allowed to scan the NFC. Then information such as who is scanning the NFC, the unique ID of the NFC, the time of scan, and the location at which it was scanned is uploaded to a server. So the tools and technologies used were passive NFC tags in each bin. These don't require external power supply, hence are long lasting. Then on the mobile app, we have the NFC reader plus camera interface that uses YOLO, that is used by YOLO DF Lite model. And the server we have used is a NeonDB PostgreSQL server. That is a real-time database that stores bin ID, timestamps of the scan, worker's ID, and the location at which the scan was done. Our app also has features for when we are not in a location where we have a network to store the data in an offline cache and upload it to the server once we are in a serviceable area. This is how the app works. On user registration, a unique ID linked to the user is generated and it is stored in the shared preferences of the phone, hence it can be called upon at any time. After login, machine learning, that is the YOLO model, is used to determine if the bin is empty. If it is empty, then it can go ahead and scan the NFC. If not, then you are brought to the step of scanning the bin until it is empty. Once the NFC has been scanned, the UID and information such as the location and time is recorded, and that bin, that information is loaded to the server. At the end, an analysis to tally of the bin is empty, and the attendance of the operator is also. Attendance of an operator is based on if he has visited every single bin that has been assigned to him. So the results were overall classification accuracy 94.2%, and
on mid-range phones, that is phones with mid-range chipset, 55 FPS was observed on those devices and an average latency of 18 ms per frame. So the challenges and limitations that we faced were poor lighting condition or occlusion can reduce the accuracy of a YOLO model. Offline scenarios required robust caching. Sync delays affected real-time monitoring. Also, model may struggle with diverse bin shapes, color, or background. Also, there is a problem with device compatibility where performance varies across smartphone hardware. Older devices are prone to lag, and damaged tags can prevent successful scans. Those were our challenges. This project demonstrated a smart AI-driven waste management solution that combines NFC technology, YOLO-based visual verification, and seamless PostgreSQL NeonDB for real-time monitoring and filter inspection. The system achieved 92.3 accuracy in classifying the application as full or empty, significantly reducing manual error or improving worker accountability. Despite minor challenges like low light detection and connectivity issue, proposed solutions such as offline logging can further improve reliability. Compared to traditional methods, this system is automated, scalable, and more transparent, making it suitable for smart city. Further enhancement includes using a larger database such as an AWS service and predictive analysis for waste forecast and route optimization. These were some of the references that we use. And yeah, thank you everyone.
Yes. What are the main limitations of your current prototype? Can you tell me, or system?
The current limitation is that NFC tags
Mm.
are prone to damage, but we are placing it on the dustbin in such a way that it cannot be damaged by people that are walking by or water may seep in. Also, as we are using a YOLO model, lighting conditions is a big problem that we face. So yeah, these two are the problems. Also, the fact that the people using this app mostly have mid-range phones that on which the app performs good but not great.
What are the different application you are considering for your project or proposed work? Where it will be applied?
Ma'am, it is actually we have made it for APCCI, that is Aadhar Pune Clean City Initiative.
Huh?
That is a charitable organization. They have dustbins around the city of Pune, and they basically clean those dustbins on a daily basis. But the problem being that the whole system is in an offline. Means how they do it is that there is a sheet in which they keep the record of when it was emptied, by whom it was emptied, and analysis is done at the end of the day. The advantage of this system was that analysis can be done in real time, and also this how can I say it? It increased the reliability on workers as they cannot enter false values as to when it was done
Have you
and if
deployed the
they
system?
actually did.
Have you deployed the system?
Yes, ma'am, it is deployed in a small scale, but we are going to be going ahead with it in a week.
So, what is the accuracy for that?
Ma'am, for the machine learning model, it is 92.3%.
Tested accuracy, no?
Yes, ma'am. And the accuracy is a little bit low because it was converted to an TensorFlow Lite model, to a TensorFlow Lite format. So accuracy was lost there.
Okay. So, is there any chance to improve the accuracy?
With a better data set, there is.
So, you will get the real data set, no, now, as you have deployed.
Yes, ma'am. We are in the talks to get a real database from them as they start in this app on. existing system.
Okay, that's it from my side.
Thank you so much,
Okay,
sir.
thank you.
Thank you so much for your presentation, sir.
Thank you.
Moving along, I would like to call upon our next presenter. Our next presenter for this session is Vishal B. Mahale, presenting a paper on the title Predicting Human Personality Through Behavioral Data Using GMM and KNN Models. I request you to kindly take over with your presentation, please.
Good afternoon, ma'am. Am I audible?
Yes, sir.
Uh, I would like to share the screen.
Yes, sir. Yes, please.
Okay, the PPT is visible.
Yes, sir. Your PPT is visible, sir.
Okay. Uh, the the title of our project is Predicting Human Personality Through Behavior Data Using GMM and KNN Model. The paper ID is 932. The group members are Vishal Mahale, Sanket Malode, Sudarshan Pagare, and Punit Chaudhary. We are from Sandeep Institute of Engineering and Management. These are the contents of our project. Uh, in the introduction model, basically we are predicting the personality of a user by using the ocean model. That is, these are the 5 main traits that are openness, consciousness, extraversion, agreeableness, and neuroticism. This model is widely used in the psychology. In simple terms, we are taking the data set and applying the machine learning algorithm on the data set and define the personality score of the user. The objective of our project is to applying the KNN and GMM algorithm. On the basis of the performance, we are taking the one of the algorithm. Um, use and we are building a scalable system so that the personality of a user can be defined in a small amount of time. The motivation of the project is that uh, we are using the unsupervised machine learning algorithm so that the cost for the training is less as compared to the supervised algorithm. And by analyzing behavior, speech, or text, machine learning can give accurate personality insights. It helps the business to understand the better and creating more opportunity and decreases time for evaluating the person. These are the literature survey. We have reviewed more than 40 literature surveys. On the we have shown the 10 literature surveys in the PPT. Now this is the architecture diagram in which we have taken the dataset from the Kaggle. The dataset is pre-processed in which we have cleaned the dataset and transformed the dataset between the 0 and 1 value and remove the unnecessary column from the dataset. On the dataset, we have applied the GMM model and KNN machine learning algorithm. And for the evaluation matrices, we have used a Debian Boundlin index, a Kalsanke-Harbaz index, and a Syllab plot. On the performance of this evaluation, we have predicted that the KNN algorithm is more effective than the GMM algorithm. Next is the algorithm identification. On the basis of a review paper, we have identified that the KNN and GMM algorithm are more effective because they are uh, less time required for processing and give more effective results. The algorithm working. Before applying the algorithm, the data is cleaned and key personality related features are extracted and representing traits based on the ocean model. These features are structured as vector for each individual, allowing the algorithm to process, and data is based on the personality characteristics. Segment individual into distinct personality groups based on the similarity in the feature value, and refine the clustering by allowing the overlapping clustering and capturing more complex personality distribution. These are the results of our uh, project, in which each graph shows the responses of the user based on each question. Basically, we have taken the dataset from the Kaggle, which having a 110 columns, out of which we have removed the 60 columns, which are uh, other information which is not necessary for the project. These are like um, IP addresses and so on. On the these 50 columns, in which each 10 columns is define the traits of each personality. These are the elbow plot and silhouette plot, in which the elbow plot define the maximum value of k, so that after which if we have taken the value, it will not effective for the model, so it defines that the value is 5, and a silhouette plot for each personality traits, uh, which defines how the data points is separated from one another. Next is the PCA graph. Basically, there are more 50 columns, so we are not able to visualize them, so that we have converted that 50 columns into 2 columns, so that we can able to visualize. The one is for the uh, k-means and another is for the GMM. It defines how the graph are how the data points are well separated from each other. The next are the results. These are the results of GMM and KMN on the evaluation matrices. The first one is the Kalsanki-Harbaz index, which defines the quality of clustering. The more is the Kalsanki-Harbaz index, the more quality of a clustering. And second one is the Silhouette coefficient, which defines how each data points is well separated from each other. The maximum, the value, the more separated the data points. And the next one is the Davis Boundlin index, is the another index for quality of a clustering. Right? Uh, the low is the DBI, the better is the algorithm. So based on the results, we identified that the KNN is more better than the GMM. When the user answers the questions, on the basis of that, we define the personality of the user. Basically, these are the scores, how the personality are categorized between these traits. So these are the different graph for different questionnaire answers. So in the conclusion, we are predicting the personality traits based on the ocean model show great potential for application in psychology and human resources and marketing. Using the large data sets, this technology can identify pattern to predict traits like openness, conscientiousness, extraversion, agreeableness, and neuroticism. However, challenges such as a data quality bias and a privacy concern must be addressed to ensure ethical and accurate predictions. Despite these challenges, with careful implementation, AI-driven personality could offer valuable insights. So this is our project Thank you, ma'am. Have any question? Hello.
Hello. Yes. Can you
Okay.
tell me the application of your system, whatever you're developing, that is predicting human personality?
Basically, the user can basically we can in hiring process, the HR can use this model to predicting the personality as per the requirement of their job.
Okay. Okay. So basically, as you have chosen the personality, so personality is a multifaceted basically. So how you
Okay.
have chosen behavioral features map to the specific personality dimensions, and for training purpose you need to train the model with these all the things. So how you have mapped the feature to the specific personality dimension?
Okay. In the data set, there are 50 columns. Which defines the each column defines the question which is treated to the each personality. Uh, so on the basis of that, we
So you
uses
are
the
using the real data set?
yes, ma'am. We have taken the data set from Kaggle.
Okay, from Kaggle. So it is a balanced data set or unbalanced?
It is unbalanced data set.
So how you handled it?
We have cleaned the data set and the value which are null or we have filled it with 0 and
That is a pre-processing
transform.
you are saying. I'm
Yes.
asking about the unbalanced data set. So if the data set is unbalanced, obviously your model will not work well. If there are too many cases of related to the same similar type of personality, so you are missing on some other type of personality. So have you handled such type of things?
Uh, Basically, ma'am, we have in the pre-processing part, we balance the data set.
Okay. Okay, no issue. Yeah. Thank you.
Thank you, ma'am.
Thank you so much for your presentation, sir. Now I would like to call upon our next presenter for this session. Our next presenter is Shreya Sai Prabhakar, presenting a paper on the title Sky Assist, Conversational AI-Driven Revenue Management System for Airlines. I request you to kindly take over with your presentation, please.
Yes, am I audible?
Yes, sir, you're audible.
Yes, once again, I'll be sharing my screen. Yes, is my screen visible?
Just a second, sir. Yes, it is visible.
Yes. So good afternoon, everyone. I'm Sriram Venkat, and I'll be presenting on behalf of my teammate Shreya Sai Prabhakar. So I'll be presenting our research titled Sky Assist, Conversational AI-Driven Revenue Management System for Airlines. Our paper ID is 854. This work is carried out in collaboration with my co-author Shreya Sai and our guide Professor Pungolil S. from Rajalakshmi Engineering College. So these are the contents that we'll be discussing. So let's start off with the introduction. So our project is basically, the thing is, airline industry operates in a highly dynamic environment where demand is inconsistent, ticket prices fluctuate frequently, and seat inventory must be tightly controlled. So traditional methods fail to adapt in real time. But our proposed model, Sky Assist, is an AI-driven system that leverages machine learning to optimize fare pricing and seat allocation. Revenue management is critical for airlines to ensure maximum profitability. So we incorporated machine learning models like random forest, cat boost, and live GBM to forecast passenger demand based on fare class and booking lead time and seasonality. So these are the works which inspired us to work on this project. So Keener, Kim, Verma, and Sharma all worked on various platforms, but we thought of making our own model in airline industry. So this motivated our use of ensemble models and forecasting in airline sector. So our problem here is, yes, static pricing system failed to address dynamic changes in passenger behavior and route specific trends. Also, there is a lack of real-time and data-driven models that can predict demand accurately and update the prices dynamically. So these are the issues that we'll be addressing using our Sky Assist model. And our proposed work is we'll start off by collecting historical data and real-time data from airline systems. So we have divided this project into three sectors. First one is flight profiling, another one is demand sensing, and then comes the adaptive pricing. So in the first step, that is flight profiling, we'll identify the routes with high demand and low demand. Here, feature engineering is used to prepare the data for model training. And for demand sensing, we'll be using random forest, cat boost, and IGBM combined together. And we'll be incorporating that to include price elasticity and evaluate how prices change with the booking behavior. So this is our modular diagram. And as I said, we'll be collecting the data set, both historical and real time, and um, we'll be using freight profiling to identify the demanding routes. And after that, we'll be using that output of flight profiling for our demand forecasting. And with the output of demand forecasting, we'll be knowing what's the best price to provide. And yes, first we'll be cleaning and transforming the data using one hot encoding, and also we'll be weekly aggregating the data. And EDA process is used for flight profiling, and EDA means exploratory data analysis. And also demand prediction is done using ensemble ML models, and also flight profiling uses visualizations to detect high demand sectors and booking seasonality. And demand sensing, as we mentioned, we'll be using random forest and collective of other models to forecast the demand. And also a feedback loop is integrated to refine predictions based on continuous booking inputs. So our model has the capability of solving the problem in real time. So these are the results which we obtained. Since we'll be using regression and numerical data, we've calculated the mean absolute error, and our proposed model has given 0.04 mean absolute error. And we compared it with other models like standalone cat boost and logistic regression, and also the R square score. Also, we've got better results from other models that we have calculated, that we have compared basically. And in conclusion, our model Sky Assist is scalable, and it's an intelligent revenue management system that adapts to passenger behavior and their booking trends. So it also enables airlines to implement adaptive pricing strategies and optimizing their operations. So in the future, we'll be integrating with a customer relationship management for loyalty-based pricing and crew scheduling, etc. And there is a room for enhancement like real-time competitor fare monitoring. Like we'll be comparing it with competitor pricing, and also we are working on that. So these are the references that we incorporated into our project that we referred. And yeah, thank you. Any questions, ma'am?
Can you tell me what are the challenges you foresee in the actual deployment of your system?
Yes, as I mentioned, we'll be using both historical data and real-time data, right? So historical
How
data,
you are going to use the real-time data?
Yes, for historical data, we obtained it through open source models. For real time, we actually used synthetic data. Since, yeah, it's a large data, we'll be using it synthetically. Synthetic data set has been used here. So incorporating that to obtain practicality is a bit of challenge for us. But yeah, we worked on it. Yeah. And also we have used various models like random forest and boosting techniques like cat boost and light GBM. And we incorporating all this in ensemble model was a bit of challenge, but we have worked through it.
So currently you're using all these models.
Yes, yes, ma'am.
So which one is having better performance?
Yeah, in our model, we'll be using all three, ma'am, like random forest, cat boost, and light GBM. These three are incorporated for demand forecasting. So
Okay.
we have compared it with standalone cat boost and logistic regression, and we found we obtained a good score of mean absolute error and R square.
Okay. Okay. Thank you.
Yes, thank you.
Thank you so much for your presentation, sir. Now I would like to call upon our last presenter for this session, Vijayalakshmi B, presenting a paper on the title Understanding Post-Menopausal Osteoporosis, a review of bone fragility and fracture risk evaluation. I request you to kindly take over with your presentation, please.
Whether I am audible, ma'am?
Yes, ma'am.
Whether my screen is visible, ma'am?
Yes, ma'am, it is visible.
Good afternoon, one and all. My research work, it is with respect to the understanding post-menopausal osteoporosis, a review on bone fragility and fracture risk evaluation. Myself, Vijayalakshmi B, I am research scholar under the guidance of Dr. Jai Sheila CS. So here today, the main topic which I'm trying to discuss is with respect to what do you mean by osteoporosis. So before understanding and before knowing with respect to what are the different slides which we are going across, osteoporosis is nothing but it is a bone-related disease which occur due to the loss of bone density. Basically, we call it as bone mineral density. When there is deficiency of calcium and phosphorus, this particular disease occurs. It occurs with respect to both women as well as men. My research area, it is with respect to women and it is with respect to post-menopause. After post-menopause, how many women are coming with respect to this osteoporosis? There are various reasons for occurrence of osteoporosis. It can be their lifestyle. It can be due to any other diseases which they have been inherited from their family. So such kind of things. So today I will be discussing about the above topic, that is the overview, that is objective, introduction, pathophysiology of post-menopause osteoporosis, imaging modalities for osteoporosis detection, comparative analysis of research articles on post-menopause osteoporosis, and texture analysis, comparative analysis of ML model performance, identified clinical gaps, and conclusion, and then the references. So in the abstraction, we'll try to see what is post-menopause, what do you mean by osteoporosis with respect to post-menopause here. Basically, post-menopause women are significantly risk for fractures. So fracture risk assessment is a critical for early interventions and then prevention strategies. This review explores advancement in fracture risk evaluation and highlighting the experimental methodologies, clinical applications, as well as emerging technologies. So from this review, I've framed some objectives. So those objectives are nothing but to review the current methodologies for fracture risk assessment in postmenopausal women, to explore the role of advanced image modalities in osteoporosis detection, to highlight the impact of texture analysis method on bone health evaluation, to discuss the integration and performance of machine learning approaches in osteoporosis diagnosis, to identify the clinical gaps and outline the future direction for improving the patient care. So in the introduction, so every year when women reaches the post-menopause, more than 50% of women are facing this osteoporosis. Basically, the areas or the sites where fracture occurs is nothing but vertebral or spine fracture, where approximately 35 to 50% of women are suffering. The other site or area is nothing but femur or hip fractures, where 17.5% of chances of fracturing are occurring. Other one is wrist fracture, which is with respect to 16%. That means for spine fracture is having what the fracture risk is more when compared to hip as well as the wrist fractures. So this is nothing but the representation where you can see the blue line, the blue bar indicate the vertebral, that is a spine fracture which is having higher chances of risk, and then hip, then the wrist here. Next is philosophy of postmenopausal osteoporosis. So this osteoporosis occur in the women, especially due to the deficiency in estrogen. So estrogen is nothing but it's a type of what the protein which is present in the bone. As the woman reaches the menopause, obviously the calcium and phosphorus deficiency occur, due to which the BMD, that is the bone mineral density, get reduced, which weakens the bone, and then the osteoporosis occurs with respect to the women there. So whenever this estrogen deficiency is present, it is leading to what? A decrease in what? The bone weakness. So when it leads to increased RNA and KL, that is receptor activator of nuclear factor kappa B lignite. It's a type of protein which automatically reduces when it reduces automatically the bone gets weakened, and then the osteoporosis occur. The other one is nothing but the tabular bone loss in the weight bearing region of hip as well as the spine here, and increased cortical portion, further compromising the structural integrity. That means because of the estrogen deficiency, there is reabsorption, because when we go with respect to what the bone, there are the different stages of remodeling of bone. One is bone formation and bone reabsorption. Bone formation is nothing but where the estrogen level increases. This bone formation occurs with respect to children. As the age increases, their bone gets what their bone strength get increases, and then the strength will be there with respect to the bone. When we go with respect to what bone reabsorption, it's nothing but with respect to what the women or the older age people, when they reach certain age, that is above 45 or 50, their bones get decreased. The bone because of estrogen deficiency, their absorption capacity get decreased, because of which they suffer with respect to what the fracture. So this we can see with respect to what are the different, these images tell about the healthy bone as well as what the osteoporosis bone. So this is high bone density or healthy bone. This is low bone density and osteoporosis. This is healthy spine. This is a spine with respect to what osteoporosis. And this is a normal bone matrix. This is osteoporosis. You can see here itself how exactly the osteal cells. These osteal cells are nothing but the cells with respect to the bone structure. Basically, if we go with respect to any organ, there are some basic units of the particular organ. Similarly, in the bone, we refer this basic unit as what osteal cells is. You can see here as the calcium and phosphorus deficiency gets decreases, automatically the scattering of cells occur, which weakens the bone there. So this is about what the matrix of osteoporosis. And here we can see with respect to that X-ray image of a normal hand and then osteoporosis hand. Here we can see exactly how exactly the fracture has been occurred. Next is these are different image modalities which is used for osteoporosis detection. So we can use DEXA, we can use HRPQC, PQCT. HRPQCT is nothing but it is high resolution peripheral quantitative computed tomography. Next is MRI, that is memory resonance intensities, and computed tomography. And the last one is X-ray. So these are nothing but what different modalities that we can use to capture the bone. So when you're going to use DEXA, the resolution is moderate there, but the radiation exposure is what low. And then main intention of using this DEXA is nothing but BMD screen. And here the key feature and limitation of that is nothing but, so it's a good standard to obtain the BMD. Basically, the main based on your BMD.
Which imaging modality are you preferring for your proposed work here? Or are
What,
you,
ma'am?
which imaging modality, as you have said here, the 5 modalities are there. So which you are using?
Basically, I am using with respect to X-ray, ma'am.
X-ray you are using.
I'm using
The
X-ray, but this
resolution.
this is review, ma'am. So in that, I have taken with respect to all, ma'am.
But X-ray is having the low resolution, as you mentioned.
Which one, ma'am? But when compared to DEXA and then X-ray, because the cost of X-ray is very high when compared to what X-ray here, because many people doesn't prefer with respect to what high cost.
Okay.
That is the reason I've chosen X-ray, and then the place where I'm staying, like most of the doctors, they are using only X-ray, they are not using DEXA. So getting the data is very difficult. Because of that reason, I've taken X-ray for the study, ma'am.
Okay, so you are using some X-ray images from the Kaggle or what? What type
No,
of
ma'am.
data set are you using?
Basically, there are two types of studies here, ma'am. One is with respect to retroscopic studies, in which we will be using the clinical risk factor. So, clinical risk factor means I'll be using with respect to like some data which I'll be obtaining from Kaggle. That is like history of the fracture, and then how many times the women have gone through the pregnancies, and then whether they are alcoholic, whether they are diabetic or smoker. Such kind of data I'll be taking from the Kaggle. Whereas when we go with respect to structural studies, I need to take the X-ray itself from the doctor itself.
Okay. So you got
In the
those data, the real-time data?
Actually, for first study, that retroscopic studies I've taken from the Kaggle. For the second one, I'm already communicating with the doctor. No, he's ready to give me.
Okay. Okay. No issues. Continue.
So here we can see HR and the PQCT. It's having the high resolution, and radiation exposure is none, and it is used for microarchitecture assessment. And basically HRPQ, it is used for 3D analysis of the data here. And MRI, it's having high resolution, radiation exposure is no. It's used for tabular bone assessment, and then there is no radiation, and then uh, getting the information is very slow here. And next is CT, it's having high resolution, and radiation exposure is high here, and it is primary application is for 3D structural defects here. And next is with respect to the X-ray, as I told. The resolution is, it is the main defect with respect to X-ray is nothing but it's used for 2D, but the clarity is good and you can easily obtain all the information which is required for the structural analysis, that is bone morphological architecture there. So these are the different type of scanning images there. This is with respect to DEXA scan images. This is HRPQCT, and this is MRI scan, and this is X-ray scan here. My research I will be continued with respect to what X-ray here. So, and these are nothing but the different comparative analysis that we have come across with respect to osteoporosis detection, with respect to the machine learning models here. So these are the first one is the first author. They have taken the method for fracture for texture analysis with respect to X-ray imaging here. They've got moderate accuracy here. Well, the limited is 2-dimensional here. Next one, they have taken commutative tomography, that is CT here, with the factorial and texture analysis here. And the accuracy, what they have got is about 0.85 with respect to the correlation coefficient for texture features here. And it is key finding is it's basically with respect to 3D imaging here, and it has high radiation dosage here. When we go with respect to the next one, that is it is used MRI for the data set. They have done the texture analysis with respect to the gray level co-occurrence matrix and fractural dimension analysis. It's having high accuracy, and key finding is that whatever the image I've obtained, they have converted from signal to noise and noise to signal to remove the unwanted disturbance in the image there. Next is the DEXA here. So it is a moderate improvement, and then for detection, and it is taking a BMD here. And it's the key finding is it is used with respect to texture analysis, but it doesn't adapt to our clinical settings. Clinical setting means only we can use images here, that is the data here. We cannot use the retroscopic studies here. And the other one is X-ray imaging, which is used with respect to support vector machine here for texture analysis. And accuracy is 85. And they're using with respect to 2D limitation of X-ray. And similarly, we have used, different authors have used different types of image modalities and different machine learning models here. And then they have told what are the deficiency they have come across with respect to their studies there. And next is nothing but texture analysis. So here basically texture analysis is nothing but it's a method which is quantify the tabular bone microarchitecture. It is directly influencing the bone strength by extracting the quantitative features like gray level pattern, structural variation, and geometric irregularities from image data. Under texture analysis, we have three types of analysis, that is fractal dimension analysis, gray level co-occurrence matrix, and local binary pattern. That means whatever the review they have done till now, all of them are followed with respect to texture analysis. Under that, they have taken FD and then GLCM and LBP here. So when we go with respect to what the fractal dimension, it's basically come with respect to, it is used to measure the complexity and self-similar patterns. And if there is a lower FD value, then obviously it reflects on the tabular bone and tells about the osteoporosis or whether the bone is resulting with respect to osteoporosis or osteopenia there. And the applications is we are using X-ray here, CT and MRI. Next one is gray level co-occurrence matrix. It's a statistical method evaluating the spatial relationship between pixel intensity. It uses three features there: contrast, correlation, and homogeneity here. And here also, if the value is less, we can easily tell whether the bone is osteoporosis or not osteoporosis, that is healthy or unhealthy bone. We are using here CT and MRI. And when you go with respect to local binary patterns, it's a method which tells about texture by comparing with respect to what the neighboring pixel here. And mainly here, to tell whether the bone is healthy or unhealthy, we capture the values of what the difference between the pixel intensity for which tells about the texture classification. Based on that, we can tell if the bone is healthy or unhealthy. And these are nothing but what the different
So,
ML
ma'am,
models as
I'm really sorry to interrupt in between. However, we have crossed that 10-minute mark way long ago. If you can conclude as soon as possible, that would be really appreciated.
oh, okay, ma'am. Thank you, ma'am. So these are different models. You can see CNN model, MRI, accuracy is 94, sensitivity is 93, and specificity is 92 here. And key strength is what it is excellent for image data. Random forest, CT, 92% accuracy, 90%, 91. It is robust for tabular data here. And SVM, it's using X-ray and 85% accuracy, 82 and 80% in specificity. It is robust for dimensional spaces here. And autoencoder, it is using both CT and MRI. Accuracy is 90, 88% sensitivity. Specificity is 89%. It's used for unsupervised feature learning. That means unsupervised means for clustering and association here. And these are the clinical gaps here: DEXA, HRPQ, biomarker, and AI-based prediction here. That is site-specific bone and superior fracture and CTC outperform traditional tools in accuracy. These are the gap identified for DEXA. It is core and diversity. For HRPU, high cost, biochemical marker, assay standardization. For AI-based prediction, required large-scale validation. That means we are getting only limited set of data. We need large amount of data to perform the more work on the particular field. So I would like to conclusion that here I've done the survey with respect to what the different ML techniques and different imaging modeling, and try to identify which is the best one. Along with that, I need to carry out this work further and need to know how exactly the women are facing the postmenopausal osteoporosis with respect to the normal women. Just I need to make a comparison with respect to both postmenopausal women as well as normal women, and what is leading them to occur osteoporosis there. Any questions, ma'am? These are the references. Thank you.
So in key texture analysis, basically, which you will be proposing for your model?
In texture analysis, ma'am, I'm planning to do all the three, ma'am.
All the three?
Yes, ma'am. Because my main objective is I've taken my first objective was to do the review on all of this. My second objective is nothing but to do the retroscopic analysis, because till now maximum they have done the analysis with respect to the structural also, but most of them have done with respect to retroscopic. So first I'm trying to plan to do with respect to retroscopic analysis, and then I'll go with respect to the structural analysis. Then if I get time permits, I'm trying to fuse both the retroscopic as well as the structural analysis there.
Okay. Your presentation shows that you have done a thorough study of your topic, basically. Good
Yes,
work.
ma'am. Thank you.
Yeah, thank
Okay. So we'll move on to the end of our session as we are done with our presenters for this session. I sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during 10th version and all the previous 9 versions of this conference. We'll be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificate through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I also would like to thank our session chair, Professor Archana. Thank you so much, ma'am, for chairing our session.
Yes, thank you, ma'am.
It's a token of appreciation, ma'am, from our end, from the team of ICT4SD and Global Knowledge Research Foundation and partners. Thank you so much for being a part of this session, ma'am. Would you like to say a few words before we end the session?
Yeah. First of all, I would like to congratulate all the presenters who have presented their work, all the authors for presenting their work basically. And I hope they all enjoyed their presenting their work in such a good conference, ICT4SD. So I hope that they will continue working in the research field and strive for the best quality research work further. So thank you all.
Thank you so much, ma'am. Now I just request all of you all to please switch on to your camera so that we can have a quick snapshot of this virtual event. Requesting all to kindly please switch on your cameras so that we can take a quick snapshot of this virtual event. Thank you so much. Stay safe and take care. We'll meet you in the next session in 2024. Thank you.